physics is easy chemistry.
Unless you look too deep and then you realize.
And then it all just becomes chemistry, because it's all the fundamental nature of matter, which is chemistry.
Yeah, but also like gravity.
Gravity is a property of matter, which is chemistry.
I know, but like everything is so complicated.
Oh, you get to there, yeah. But that's because they're doing chemistry at that point.
We can't accurately describe gravity.
Says
Not yet.
Isaac Newton.
Theoretically, we can. Eventually.
With more than
Isaac
two,
Newton says
with more than two
otherwise.
objects.
Okay, where'd my, there it is.
I love how when we did predictions of the orbits of the planets and Mercury was roughly 1 millimeter off its proper path, in reality it crashed into the sun.
Where, hold it. All right, quickly do attendance. Please answer here or present. Aiden.
Yeah.
Arnie. Bowen.
Here.
Graham.
Yep.
Grayson. Grayson?
Grayson's here.
Oh, he's moved out. I knew that. Jamie. Layla. Liam.
Here.
Murray.
Is here.
Who's here? Matthew. Miyabi. Nick. Noah. Rachel. Rose. Violet. And Yuma. Excellent. And then call, let's see, 1, 2, 3, 4, 5, 6, 7. Identify these as one of those three types. So this is either synthesis, single replacement, or decomposition. First come, first serve as to which one you want to do. What did I say? 6? So that is Yuma, Noah, Rose, Bo, Matthew, and Rachel. Nice. And I have one more demo as the last person doing it.
It's a big beat.
Okay, we are clearly done. Let's start. Are you ready? John?
I just used my hand.
Got everybody? Fred? Single replacement, a single and a double. Yep. One thing, going to be a decomposition. That's the only thing it can do. Two things that are very simple, elements coming together, synthesis. One thing, going to be a decomposition. Two simple elements coming together, going to be a synthesis. A pair and a single, that's going to be a... Oh, did I not call enough people? Only 1, 2, 3, 4, 5. Oh, I didn't call 7, so someone picked this one. One thing with a pair, so single replacement. This is also a pair and an element, so this will also be a single replacement. And do we have, oh, we do have more. I'll just call those up now. I'll give you the moment that I call you. First person, Arnie.
Yeah.
What is that?
That is
Synthesis. Despite the fact it is 12 things, it is basically two elements coming together to make a compound. Nick. Decomposition, one thing splitting apart. Violet. Synthesis. Bromine coming together with iodine, making iodine bromide. Okay, the next one, the double replacement reaction. Now, what should I use for this one? Perfect.
Oh, this is very scary.
Hold it. Have it with Ryan and Arnie. Think Aiden and Nick.
I wanted to get fixed so hard.
Yeah, but then come. What do you do? Why are you still looking at me? Come on. Okay, in this one, you can tell like and unlike by the basis of their tie. So we have turn. This face the audience. The audience. So red tie. And what is this? This is the 100-year tie, century tie. Excellent. So we have a century tie with a red tie. So move a little further that way. Yeah, because you got to be a little separated, a little further over. Go that way more. Okay, now we're once again. You are in love. Look at each other's eyes. Dance. We are once again at the dance. Dancing. There, excellent dancing. But now this is the skill testing part. You look across the room and switch partners correctly.
Come in here.
Okay. Have they switched partners
Yes.
correctly?
Yes, we have.
No, they have not.
Oh.
What's up?
There we have it. Like replaces like. So metal replaces metal. Non-metal replaces non-metal. I leave it up to you to decide which tie is which. I have had it before where I say switch partners and they both switch. They end up with the same person they had before. You can only imagine that going on forever. That would be hilarious. Please give them a hand for this last application. Well done. So calcium replaces sodium. Joe? Aiden? Calcium replaces sodium, so you get calcium chloride instead of sodium chloride. And then the chlorine replaces the nitrate, so you get sodium nitrate. If I was then to write this as AC, oops, sorry. Might as well go in alphabetical order. AB plus CD. What are my products? Say it? That is my reactants. What are my products? CD? D? B? AC? No. You did the same thing you did up here. If this is in front, is it a metal or a non-metal? And this is also a metal. So in this particular case, AD, nice. Okay, well, one at a time, because now you just call it. So A what? AD and? CB, nice. Because it's first here, it has to also be first there, because the metal will always go first, and then you can figure out the order. I now change this, because I was informed that the type of dance this will happen in is if in your Alberta, they do a thing called line dancing. And there's something called the do-si-do or something, and everybody switches partners. If anybody's from Alberta, if they could confirm if this is a regular practice. So line dancing, you switch partners. So a double replacement in terms of a demo, I have
Yippee!
for your viewing pleasure today, and lead nitrate. There is no,
If you drink that, won't you?
please, hands, rather than calling out. Lead nitrate. There is no danger of blowing up, but there is a danger with these two compounds. What would that danger be?
Gas.
Hands. Yeah? No. What is the danger?
Like a gas coming out of it.
No gas.
Drinking it.
But what is the danger in those two compounds? Lead. We got lead poisoning. If we put them together, however, it turns a brilliant yellow. Now, what are the two possibilities for that brilliant yellow? If we started off with potassium iodide and lead to nitrate. Potassium nitrate or lead to iodide, and it is in fact, that's supposed to be a solid symbol. It's the lead iodide that comes off as a solid. This is used, or used to be used in lead paint. It's still used in lead paint. There were some toys that were recalled in Canada a few years ago because Big Bird from Sesame Street was painted in this. It was a children's toy. And of course, if children get toys and they chew on them, then they're swallowing lead paint. We found out about this in terms of human history because it was very common at one point to have cribs. You'd paint a big yellow bird, chicks on the side, and roosters and hens and barnyard animals, and all the little tiny baby chickens would be all little yellow colored. And then they trimmed the bed in yellow, and it was lead iodide paint. And then they would chew on it, and then they would get lead poisoning. How many of you have not seen Toy Story? Oh, sadness. Next, you are actually quite lucky. Now you get to go watch Toy Story. What was the name of the maladjusted child next door that ripped apart his sister's toys? Sid had environmental causes for his behavior. If you look when they're on the window and they're trying to escape his room, there's a distinct cracking pattern in the paint. It has long rectangular cracks. That is absolutely a sign of lead paint. It's white lead paint. It's not lead iodide. I think it's a type of lead oxide. And Sid, and it's very noticeably coming off. It's in the bottom on his rug. Sid is taking in lead paint. All of his behaviors are classic lead poisoning. Inability to control his temper, inability to focus, not having as much empathy for others. They're all signs of lead poisoning. And so the story is made a little bit more tragic by the villain of the story, villain if you can call it that, they put the environmental causes for his behavior right in the film.
Do you die from lead poisoning?
You can if you get enough. We have seen since the 1920s, we've seen a lowering of violence in society in terms of the amount of muggings, murder, and everything else. If you do it per capita, and it is tracked with our outline of leaded gasoline. And so one of the theories right now is that our old habits of violence actually caused the entire population had some amount of lead poisoning. And as it's leaving the environment, it's going away from the population. I don't know how much you'd have to take for it to be lethal, but you'll get behavioral effects long before you get to lethal levels. Unless you take a huge amount all at once. Neutralization. This is also a special double replacement, but we identify it separately. We identify it separately because on planet Earth and having water-based chemistry, this type of chemistry is particularly important. We want to be able to recognize it when we see it because it is a variety of different things. First, we have to identify the acid. The acid always has hydrogen. So an acid is defined as something that gives off H+, and a base is defined as something that gives off hydroxide. Maybe I'll do that in a different color so we can separate the two. So you always have some kind of acid and then some kind of base. So it'll always make because the H and the OH come together to make H2O. And then what would be the other product that would be left? This is similar to the double replacement from before. We've taken care of all the H's. Ba. We've got the metal here for the hydroxide. We have the non-metal there. And so we will always make that. This portion is the salt. All products that are the leftover portion are known as salts in chemistry. So table salt is HCl plus NaOH goes to H2O plus NaCl. Table salt is just one type of salt. Sodium sulfate is also a type of salt. It's just sodium chloride is actually edible. Well, in relatively small amounts. You can get lethal doses of that as well. You can also underdose. If you are hiking or doing a lot of physical activity, sweating an awful lot, and you're not rehydrating and you're not taking in more salt after, and I say hiking because often people are very careful about the food they bring because they have to haul that food. And for those, they often may not pick things that are salty enough, and so they'll take along salt pills because you can actually run out of salt if you sweat enough. If you run out of salt, your nerves don't work properly, and that itself could be a problem. So it's a special type of double replacement. I would like you, now we're going to skip these because I want to do those as a lab, and that's not going to be on the cumulative. I'd like you to go through here and first identify all the ones as a neutralization. So is it an acid base or neutralization? Then when you're done, for the leftover ones, what type of reaction are they? I've put water in different spots. You've got a couple different reactions. You look confused. Flip ahead a couple pages. There you go. Okay? Oh, no, ignore that. I printed it on here. I used to do it as like you'd go online and do it, but by the time everybody gets their computers out, it's okay.
Which one's the neutralization? Then which one's the acid?
Oh, acid base and neutralization are the same thing. They're two names for the same thing. So you just put N or A/B if you want to do acid base, it's fine. Acid base and neutralization are they're two different names for the same reaction.
Then why is it like, is it acid base or neutralization? And is
Just so I'm including both things. Is it acid base / neutralization would be another way of saying that sentence.
It gives off a hydrogen.
I get
And
it.
what makes it go makes the
Do you get it?
Find the ones that are acid.
You're not confused like that?
it gives off an H plus. And the base is it gives off
No, it's the same thing.
hydroxide.
So here's the one that you'll always see.
Binds hydroxide and something with hydrogen and oxygen.
So then there's also ones
And
that
then
are
the metal from the OH will always be there.
That's
in the
the
salt. And then non-metal from the acid will always be there. And that
Acid base
salt.
and neutralization of the
So it'll always get HOH,
Is it a
water,
synthesis?
and then you'll see those just combined. Or before, like the order doesn't. Yep.
First one's synthesis.
Pardon?
I'm so good at this.
Oh, these are just made in like
I'm so confused.
yeah, in a particle accelerator. They don't exist long enough to determine the charge.
Yes or no?
Eight, yeah. Yeah.
No on all.
So for determining what you're looking for, on the first one, you're looking for an H
I'm not.
and an OH.
I'm not nothing.
If you find both of those, double check that it makes a water. It'll always be a water, then in the other case, it should look like the other two, and that's what we're doing. Yeah. First, just figure out which one of those are. I'm gonna go help others. I already helped you. You can do the other ones. We're gonna go over it. A plus B equals B plus A. So if they're separated by a plus sign, they could be in either order. Does it make sense?
There's no NaOH.
No. Good. looking
that
good.
how it is? Good.
I don't see any writing now.
Oh, yeah. I think it's.
So then not good. Why would you say good? Aha. Good. Okay. So look, both of you look this way. What you're looking for
No, it's a double replacement.
is you're looking for
So
an
as long as
H
it has that hydrogen
on
and
one
that
of them,
side
doesn't matter which one, and an OH. HOH. Then that should make water. So it will always have it.
Okay.
The other piece should just have the other bits jammed together.
Okay, got it.
So you're just
The
looking
last
for
one, the
HOH.
last one and the third one.
Wait, but we just have H and O. There's no OH.
Which one?
Here.
That's a no. That's a no. Yeah.
Oh, so it's yes, no.
Yeah.
Is this no?
You can just go yes, no. When you're done that, then the ones that aren't, I want you to identify as one of the other ones.
Separate, like OH or something.
You should see an OH at the end. Yeah.
Wait,
That's
so
no as well.
This is a no as well, right? There's no OH in HO.
Where now the H and the OH should be at the
Here.
beginning.
Oh, at the beginning, okay.
Yeah.
Well, this is OH at this step.
Yeah.
This is O.
Yeah. So you got an OH. Do you have an H? Yeah. Used to make water. H2O. Yeah. Does it have the other ones put bashed together?
Yeah?
Yes.
Oh, so then yes.
There you go.
Okay, wait, I still have to write it down separate.
What? Yes.
Is all the reactions beginning or are we doing like
Wait, is this?
We're doing one more.
combustion?
We're doing combustion.
Wait, there's no, right? There's no. There's no OH.
Any good?
There's no OH, but how?
Oh no, no, no. Because what you're looking for first step is it an acid base? An acid base.
This is such an old sticker.
You have an H and an OH on someone in the beginning. Then it has to make water.
Ow.
So you have to see an H.
Feed you twice the LP of
And then on the other side, you will always see a water. Okay? And then whatever left over should be made up of the other two pieces mashed together. So NaSO4 and NaSO4. Yeah. So now the ones you said no to, identify their type. Okay?
I didn't get fully because I watched them like this.
The reason also it can't be a single replacement. A single replacement has a pair, but then it has a single element that's replacing this.
Yeah, my mom was
This
watching
it
it.
has
She was like
to
texting me about it. She was like, "You watching the vlog?" I said,
it has an H, doesn't have an OH in the other one.
I know, I wanted to go.
"Yeah, we were all going in."
Good? Good?
We think so.
Okay?
No, no, yes, no, no.
Okay. I'm going to call 1, 2, 3, 4, 5, 6. All I want you to write on there is yes or no as to whether or not it's an acid base / neutralization. So you don't have to identify the type. Other just, is it an acid base? What time does this class end? Okay, 5 minutes is more than enough. So that's 1 to 6. So Liam Baker,
Oh, okay.
Graham,
Uh,
and click, darn you. Aiden, Miyabi, and Bo. Ooh, we cleaned out the entire front row. And then for my next,
Trying to help me out here, bro. What's this one? This one's a no.
no, you only followed 5.
Or someone didn't go up.
Oh, who didn't go up?
okay.
Someone didn't go up.
So the double check. We have H, OH, making water. Looks good. We have H, we have OH, making water. The other ones are joined together. Looks good. We have an H, but we have no OH. Good. This is also a synthesis. This one have an H, no OH. So this is a weird double replacement. We have pairs exchanging. Yes. This, we have an H but no OH. It does make water, but there's no OH. So it is a decomposition, so that's good. There's an H, but it's water and on the wrong side. In fact, our acid is on this side, which is weird. There's no OH at all, and it's not making the salt. So definitely no, this is a synthesis. OH, yep, we already did that one. Last one. My favorite reaction, because it helps with the voices.
The voices, they're crazy.
Well, you know the voices.
That was
Yeah.
crazy.
The ones that say that everything would be better if it was cleansed in fire. So, next reaction is a combustion. Obviously, they're a very exothermic reaction in every single case. It is pretty. What I really find interesting, I don't know if you can see it from here, is the ash still has the ink on it. The ink doesn't go away. Ink often has metals on it. If you chew on paper, it's not actually the paper that's the problem. The paper is mostly just fiber. It's pretty good. But, too much smoke with that one. But the ink contains some metals that you probably shouldn't eat, and you probably shouldn't eat that. A combustion always has some sort of carbon, hydrogen, oxygen thing. Have I got everyone?
Smells a little smoky in here.
It always has oxygen. So this is always there. It always gives off H2O, and it always gives off CO2. It is one of the easiest ones to recognize because you just look for some carbon, hydrogen, oxygen thing, reacts with oxygen, gives us H2O and CO2. So if I gave you glucose plus oxygen, what does that make? Water. And what organelle does this take place in? This is the mitochondria. So you are literally, this is why can be referred to as a combustion engine. You take in oxygen, you burn the glucose, and you give off water and CO2. Before you go, you need a worksheet? Oh. Yes. But I think some of them are in the photocopy room. Grab. First come, first serve. The rest of you, if you don't get one, you have to wait here till I run upstairs and grab more. Oh, there. Wait here. I'll be right back.
I have, but that was just when I was in grade 8. 2 group of kids went there on their grocery cart.
Why does it smell like this in here?
Because you just burned a piece of paper.